an AIDS charity initiative. Powered by the Malala Fund.
Hello students, this broadcast is for secondary school students. My name is Mrs. Oluwaseun Oteniola and I'll be teaching you H.C.F today. I guess someone is asking what H.C.F is. H.C.F means highest common factor. Yes, H.C.F means highest common factor. I'll start by explaining what factor means. Factors are numbers that you multiply with another number to give a product. I'll take it again. Factors are numbers that you multiply with another number to give a product. Let me simplify it further. We know that 2 times 3 equals 6. So, 2 is a factor that you multiply by another factor, which is 3, to give you a product of 6. Hence, 2 and 3 are factors of 6. What about 1 times 6, which is equals to 6? 1 is a factor as well as 6, because when you multiply both of them, you will get 6. Hence, 1 and 6 are also factors of 6. Great! Now can we find all the factors of 6? Yes, we can. 1, 2, 3, and 6 are all factors of 6. Well done, guys. Can we go ahead to find factors of 8? Let's go ahead to find the factors of 8. The first question you should ask yourself is, what number do I need to multiply together to give me 8? What number do I need to multiply together to give me 8? Let's find out. 1 times 8 will give us 8. Yes. 2 times 4 will also give us 8. Correct. That means 1, 8, 2, and 4 are all factors of 8. 1, 8, 2, and 4 are all factors of 8. I can also go ahead to rearrange the numbers as 1, 2, 4, and 8. Now, did you notice that 8 can divide through all its factors without a remainder? Let's check it out. 8 divided by 1 is equal to 8. 8 divided by 2 is equal to 4. 8 divided by 4 is equal to 2. 8 divided by 8 is equal to 1. Wow! Very interesting. Let's go ahead to find common factors. Can we find the common factors of 6 and 8? Factors of 6 are 1, 2, 3, and 6. While factors of 8 are 1, 2, 4, and 8. Can you tell me the factors they have in common? Yes! It's 1 and 2. Correct. Can you go ahead to pick the highest of these common factors? It's 2. This is quite easy. Let's find the H.C.F of 15 and 18. Let's go ahead to find the H.C.F of 15 and 18. The first step is to find the factors of 15 and 18. The first step is to find the factors of 15 and 18. To find the factors of 15, need to find the numbers that I'll multiply to give me 15. Let's go ahead. 1 times 15 will give me 15. 3 times 5 will also give me 15. Do I have any more? No, that's all. Hence, 1, 3, 5 and 15 are all factors of 15. 1, 3, 5 and 15 are all factors of 15. I'll need to also find the factors of 18. 1 times 18 will give me 18. 2 times 9 is equal to 18. 3 times 6 is also equal to 18. That means 1, 2, 3, 6, 9, and 18 are all factors of 18. The second step is to identify their common factors. Factors of 15 are 1, 3, 5, and 15. While factors of 18 are 1, 2, 3, 6, 9, and 18. Can you tell the factors they have in common? Yes! 1 and 3. Great! Finally, can we tell the highest common factor here? It's 3. Fantastic! Fantastic! Let's try our hands on this. Find the H.C.F of 20 and 30. Find the H.C.F of 20 and 30. The first step is to find the factors of 20 and 30. Factors of 20 are 1, 2, 4, 5, 10, and 20. Factors of 20 are 1, 2, 4, 5, 10, and 20. Factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. Factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. Can we find their common factor? Yes! They are 1, yes, 2, 5, and 10. Great! Good job! Let's find the highest of all these common factors. It's 10. Beautiful, beautiful work today. I'll advise that you practice more examples on your own. Don't forget the saying, practice makes perfect. Till I come your way again, have fun and stay safe.
This is an ACE charity initiative. Powered by the Malala Fund. Hello once again, children. If you have any questions about what you've learned today, please text 070-3630-3182.
This broadcast is for secondary school students. Hello listeners, I am Adesami Temitayo, your ACE Radio School English teacher. In our previous lesson, we learned about concord, which is the agreement between subject and verb in a sentence. And of course, we looked at a couple of rules governing these agreements. Today, I'll be teaching grammar with the topic phrase. Can you repeat after me? Phrase. It is spelled P-H-R-A-S-E. Phrase. What is a phrase? A phrase is a small group of words without both a subject and a verb, otherwise known as predicates. A predicate is the part of a sentence that contains the verb and says something about the subject. Phrases are a short group of words that adds meaning to a sentence. A phrase can therefore perform the function of a noun, adjective, or adverb. Phrase can be short or long, but it does not include the subject with verb and object together. When you have a subject and the verb with the object, which is the receiver of the action, it will no longer be a phrase, but a clause. Another big word, right? Don't worry, I'll explain the meaning of a clause. A clause is a complete sentence with a subject and a predicate. So you can see, unlike our phrase, a phrase will never contain the subject and the predicate. No. But a phrase can form part of a sentence. Are we following? A phrase can only form part of a clause, which is a complete sentence, but won't give complete information. Take for instance the sentence, John lost his shoes. John lost his shoes. The whole sentence is a clause, while the phrase his shoes forms part of that sentence. There are basically 5 types of phrases. We have the noun phrase, verb phrase, adjective phrase, adverb phrase, and prepositional phrase. I'll be expanding more on these phrases type in subsequent lessons. Let's take a quick look at some examples of phrases. Remember, we said a phrase is a combination of 2 or more words that forms part of a sentence. And of course, we said a phrase will never contain both the subject and the predicate. And what is a predicate? Predicate is a verb and the object that gives us more information about the subject. These are examples of phrases. Singing in the room. Along the road is another example. The brilliant head teacher. That's another example. A wicked hunter. That's another example. Without enough money. It's another example. Give away. So these are phrases. If you notice, they do not convey a complete information. If I just ask you, or I just converse with you and say, along the road, you feel there's something missing. It's just part of a sentence, but not a complete sentence. That's a phrase. And I just say, a wicked hunter. You understand? It's just a phrase. Or I just say, give away. It's a phrase. It's not a complete sentence. Okay, test time. I'd like us to test ourselves and see if we can identify phrases from these sentences. Are you ready? Now listen to the following sentences and see if you can identify the phrases. Sentence 1. Mariam is fond of singing in the room. Mariam is fond of singing in the room. What is the phrase in this sentence? If you have underlined singing in the room, you are very correct. You just got that question right. Singing in the room is a phrase which forms part of this whole sentence. Mariam is fond of singing in the room. Sentence 2. The man at the door is waving at me. The man at the door is waving at me. Can we identify the phrases or phrase in this sentence? Good. If you have underlined the man at the door, or waving at me? You are very correct, because we have two phrases in the sentence. The man at the door is a phrase, and of course, waving at me, it's another phrase. But we cannot say the man at the door is waving at me is a phrase. No, that's a clause. It's a complete sentence. But we could have a couple of phrases or a phrase forming part of that sentence. I hope we are getting it. I will leave you with some assignments which you will do and text to the number that will be announced on this platform. However, let's have a brief recap of what we've studied today. We looked at a phrase, and we learned that a phrase is a combination of two or more words that don't convey or that does not show a complete information but can form part of a sentence. And we said the phrase will not contain a subject and predicate. And what is a predicate? We said the predicate is that part of a sentence that contains both the verb and the object, which says something about the subject. We looked at 5 types of phrases. We looked at the noun phrase, the verb phrase, adjective phrase, adverb phrase, and prepositional phrase, which I promised that in subsequent classes I'll be explaining them better. We looked at examples of phrases and how we can identify phrases in a sentence. And of course, we looked at the function of a phrase. Now listen to the assignment I'm going to give you. I will read out some sentences, you write them out, identify the phrase, and submit by texting your answers to the number that will be announced immediately after this lesson. Question 1. Sentence 1. John is writing in his new notebook. John is writing in his new notebook. Sentence 2. Aisha is a student in my class. Aisha is a student in my class. So I need you to identify the phrases and submit your answers via text message to the number that will be announced. This is where we wrap it up on today's English lesson. Until I come your way again, it's Adesami saying bye for now.
This is an AIDS charity initiative powered by the Malala Fund. Hello once again, children. If you have any questions about what you've learned today, please text 070-3630-3182.
This section is for secondary school students. Hello students, welcome to ACE Radio School. My name is Mark Ibrahim and I'll be your physical science teacher for today. Today, we shall be studying physical quantities and units. Sit back, relax, get a pen and paper as we go on this interesting journey. Science has been defined as measurements by some scientists. You might ask, why would a scientist define science as measurements? This is because scientists carry out a lot of measurements. For example, physicists measure physical quantities, while biologists measure biological quantities. When we talk about physical quantities, physicists have grouped physical quantities into two groups. The first group is known as fundamental quantity, and the second group is the derived quantities. We will start by looking at what fundamental quantities are. Fundamental quantities are the quantities from which other quantities can be derived. Another word for the word derive is gotten. This is to say, if we look at physical quantities as a building, fundamental quantities would be the foundation. They are also known as building blocks. Other scientists have referred to fundamental quantities as base quantities. Examples of fundamental quantities are length, mass, time, electric current, temperature, amount of a substance, and luminous intensity. Wow! So if fundamental quantities are the foundations of a building, then what then makes the rest of the building? According to physicists, the other parts of the building are referred to as derived quantities. Derived quantities. All other physical quantities that are expressed as a combination of the fundamental quantities are known as derived quantities. Now, what are examples of derived quantities? Examples of derived quantities are area. I'm sure you have been taught the formula for calculating the area of a body in your maths class. Now, just a quick reminder, the formula for calculating the area of a body is length times breadth. Now, in physics, we see breadth as a form of length. This means whenever you measure the breadth of a body, you are also measuring length. I hope you understand that. Therefore, area is a derived quantity from the combination of length multiplied by length. Another derived quantity is volume, which is derived by multiplying length times breadth times height. Oh, I can hear you saying, yes, but the breadth is length. That is very good. And I would want to also inform you that height is also a form of length. Therefore, if you measure the breadth of your sitting room, the length of your sitting room, and the height of your sitting room, you would have just measured length. So, the formula for volume, which is written and represented as capital letter V, is length times length times length. That was real fun. Now, can you give me other examples of derived quantities? Next, we would be studying units. Let us start by applying a little of our imagination. Imagine you wrote a letter to your friend in another state, informing your friend that you have been unable to attend school for the past 2 because of the COVID-19 pandemic. Oh, I can hear you asking, to what? Yes, just writing to will definitely leave your friend confused. he or she will be unable to know if you meant 2 days, 2 weeks, or 2 months. To avoid such confusions, scientists have agreed on a general language for describing physical quantities. This language is known as the International System of Units, or the SI units. These units are usually placed after the measured physical quantity. So, in the example above, after the 2, which is the value of your measured quantity, you would have to add a unit. The unit could be seconds, hour, it could be 2 days or 2 weeks. Now, let us quickly look at the SI unit for a few of our fundamental quantities. The first fundamental quantity, length, has an SI unit known as the meter. The next, mass, has an SI unit known as the kilogram. Time has an SI unit, second, while temperature has an SI unit, Kelvin. Electric current has an SI unit, ampere. Now, the SI unit for temperature and electric current are named after famous scientists. Oh, I hope one day we would have a unit named after you. You might ask, if fundamental quantities have units, what about derived quantities? Oh yes, derived quantities also have units. For example, the unit of area is expressed as the unit of the fundamental quantities from which it is derived. Therefore, since area is equal to length multiplied by length, its unit is meter multiplied by meter. You would remember the SI unit of length is the meter. Therefore, the SI unit for area is known as the meter squared, written as lowercase ms raised to the power of -1. In our next class, we would be looking at the topic dimension. But before I end this section, can you tell me the unit of volume?
This is an AIDS charity initiative powered by the Malala Fund. Hello once again, children. If you have any questions about what you've learned today, please text 070 36 30 3182.